In this episode, we're going to discuss meters and snap-on meters and their history of the digital meter itself and the evolution that took place from literally the late 70s all the way through to current, and how to approach the meter, and if you're going to be buying a meter, a used one, new one, have an understanding. This will apply to any high quality automotive meter. I'm just utilizing Snap-on because of my extensive background and familiarization with that particular product. But I said you can apply this to many others. So what we're going to do here first is we have all the meters I'm going to be using in this presentation. The MT470 to MT500, and then we go up into one of the really common ones is the 525, and it's, I guess we'd say, upgraded version with the large display, and then kind of a universal, works in many trades meter here. This is our 575, and then there's also the hybrid and EV car meter. So we're going to talk about all these different facets. The first meter we're going to discuss today is the MT470. This was the first introduction to Snap-on's digital lineup of multimeters, or DVOMs, whichever term you want to use. And this one goes back to the late 70s. It was superseding the analog style meters. But we all were, at that point, not real familiar with the digital environment. Man, we're pretty much on analog time, so the technicians of the era had to get familiar with it. It had the leads, non-replaceable leads, as far as non-replaceable, like you would in a common modern meter where you simply unplug from the banana jack and plug in a new one. These were hard mounted in there and had to go to the service center, or you had to be pretty handy to do the replacement. Had to look standard little cover here that the leads went in. So there was some benefits to this design and some disadvantages to it. Let's go ahead and get testing going. Today I'm going to use a little simulator board, and what we're going to do is a couple simple tests. The first one is I'm going to look at just the DC voltage being brought into the meter. So I've attached to ground and just an analog signal that's going to be brought from a low voltage up to a higher voltage. So take careful note of the response speed of the meter itself. LCD display for its era is actually really good. Remember, displays of that time were very challenging compared to what we're dealing with today. So this is what technicians that would have been working on that 1970 Hemi Cuda, the 1975 little Honda Civic that was out, all of that was being serviced with this type of tool because that's the cars that were being serviced in that era when this came out. It continued on. It was a very successful product, but it got superseded by many different designs. So let's look at it again here. You can see the response of the display. Now let's go over here to the next one here. This is going to be a duty cycle. So it's a 50% duty cycle. And I'm just going to change the frequency. For the most part, the meter really is quite amazing for its time and its accuracy. This was not a true RMS meter as we know today, but its ability, so its build allowed it to actually work at the same quality, or darn close to the same quality we'll see with a more modern meter. The next hookup we're going to do is this going to be a varying, it's a varying duty cycle signal. But what it's going to be doing is we're going to vary that duty cycle, so the on and off time. So as you can see here, We're at a full 5 volts, 100% on time, 100% off time. So it's tracking that square wave amazingly well. Amazingly well. I'm pretty impressed with its performance. Now, the plan for today's session is we're only going to look at the DC function. So I want you to take note that we have 4 manual settings. There's no auto setting on this. So you had to anticipate what you're going to be working on. Not a big deal on the volt portion. The ohms was a little more challenging of that time. But pertaining to the volts, normally the normal setting was right in the middle. You would simply set it at the 20 volt. Would address most everything that you would be dealing with of that era. This is the MT500. It came with a blow molded case on it. It was built by engineering in Kenosha, Wisconsin, as was the MT470, so that was homegrown. This meter was a little different in a sense that it was more designed for strictly technicians, drivability technicians. It didn't really address the HVAC, the electrical industry. It was intended to be an automotive. So if you could see the displays, you have your normal volt ohm and a shunt style amperage. We will be covering that in a later session. But the voltage on this one only goes up to 30 volts. The intention was that was what was designed at that time, and it was simpler to keep it down in the range where technicians would normally be doing their tests. So let's go ahead and run it through its paces. I'm set at the 20 volt level. We'll hook up to our DC. Display is pretty comparable to the previous meter. It's moving up and down at a nice rate. Let's go see how it does on a 50% duty cycle, varying. So we're going to vary the frequency. I think she's sitting a little bit lower on the scale, and that mainly is because this is not a true RMS meter. It wasn't designed to be. It was a more middle of the road design of the time, focusing on the automotive. So the view was the full RMS wasn't that important. It actually was, but it was deemed at that time from a engineering and marketing standpoint of not being that critical. Now we're going to move over here. So we're going to vary the duty cycle. It doesn't quite achieve the 5 volts. We can turn it off, but we can't quite get it. So it doesn't see that varying duty cycle as good as the previous meter. So these are things to keep in mind. So this is not a true RMS. This meter was designed and built in the mid-80s. It's a good tool. If you got it, it would still work extremely well for today. For standard voltage drops, system voltage, anything of that nature, wouldn't be hesitant at all if you happen to find it. Now this is an old meter, so relatively hard, more on a, I should say, the classic level. But it is still viable today. One of the things that makes it unique is its ability with the tachometer, the duty cycle. And I said in a future presentation, I will cover how the shunt style worked on this particular design. It was very interesting. Okay, the next one we're going to go to is the 525E. This is the 525E. It's your bread and butter. You can see this is my meter here. I have all of them are, but this one here has got a lot of use. It's kind of the one I use for all my tasks here on my farm. When I do troubleshooting throughout at a variety of different dealerships and repair facilities, it's kind of my meter of choice. And it's almost like wearing a glove. It reminds me an awful lot of a glove. It just works. It's in my hands. It works every day, and it literally works every day. Now, the meter itself is a category 3, so now we're going to be talking about something a little newer. It's intended to work on a high voltage. It can work up and around a 600 volt. It has to do with safety of the meter itself and safety of the operator. So the installation is a true RMS meter. So we're going to go ahead, we'll make our same hookup. Now this has, like the other one, had the banana jack replacements. But it does not, that MT500 would not use the modern insulated banana jacks. So these insulated banana jacks here are a little bit different design, and that other one won't. But this is the standard lead set you'd be anticipating using on all modern meters. Okay, let's go ahead and we're just going to simply vary our DC level voltage. I've got it on auto range. We didn't have on the other two. This has got the auto range function. So I don't have to guess what my input voltage is going to be. But for this demonstration, I think we'll do is we'll go ahead and we'll set it up right about there. I think that would be a good spot. So we would show 2 increments in the millivolt range, and then we'd have 2 segments, 2 increments there, in above the 1000 millivolt range. So we'll have a chance to see up to 99 volts. Of course, we won't hit that. A couple things I want to mention is that it has the 4 manual ranges in it and the 1 auto range. From a testing standpoint, my experience has been typically stay with the manual range. Auto works if you absolutely have no idea what you're going to be up against. But the hunting of the meter itself can be distracting from a troubleshooting standpoint. Well, let's go over here to our fixed duty cycle varying frequency. You can see this is a true RMS meter. It is rock solid throughout the range. Until the voltage went away, it just simply stays there. So it's doing the calculation under the curve. So you have 50% up, 50% down. At a 5 volt level, we are coming up with a very accurate number to work with there. So that very accurate number is displayed. So that is exactly what this, if you took a lab scope, this is what you would find. So this meter is tracking true. Okay, now we're over here, and now we're going to have that varying duty cycle. So we're varying our on time. You can see the bar graph here is actually displaying, so it's fast enough to see the fluctuation of that duty cycle. So the variance is as it goes in and establishes points that it's going to measure, it's seeing it's moving and moving, but the processor inside here is doing an excellent job of keeping that locked in. Now we have the 525F, or simply the large display version. This is really handy for hanging it underneath the hood or under hood type activities, what we'll show in some future videos. We'll go ahead and run the performance of it right now. I've got it currently in the auto range. So same hookup as the other one. Go to our ground. We're going to go to our DC value. And I'm going to go ahead and I'm going to change the DC value. Now I've got it in auto range. So our display is bouncing around. For ease of view, we'll go ahead and we'll set it up right there. Same as the previous meter. One of the nice things on this one is simply the large display. Very easy to see. It's a little bit more like a scan tool from a performance standpoint. This one is actually got a class up, so it's a category 3 and 4, so it's intended to work in the hybrid EV environment. So that environment is a little more robust, so we want to have a meter that is capable for safety of the meter and safety of the operator. So always make sure you check what category level the meter is. It's critical when you buy one, and also critical that you get a true RMS meter. And again, in another future edit video, we'll go ahead and go in depth on RMS, but right now, just take my word, it's critical that you have a true RMS. Cheap can be expensive when it comes to doing diagnosis. So whatever brand meter you have, make sure it has these characteristics. And as I've worked on a lot of EVs and hybrids, and that world is going to be a little different if you're not familiar with it. So make sure you have the right tool for the right job. Let's go ahead and run this down through its paces. Fixed duty cycle, and we're going to vary the frequency. Again, basically just holding rock steady. This is a little faster response, a little faster processor in it, so it's seen a few of the variations within it, but they're just dead nuts. We're down in the mud here trying to make a variance, but from a troubleshooting standpoint, this is the kind of tool that you want to have. And again, the bigger display makes it a little bit easier. I guess my older eyes here, it is handier, but it is bigger, so there's a trade-off. When you do crawl underneath the dash, this bigger display really shows its strength. In some of the rough and tumble areas, the conventional meter configuration is I would say, kind of preferred. Let's go ahead and move it over to the next area here. Now remember, this one we're changing the duty cycle, the length of time that the signal's on. True RMS meter is going to tell us the value of the signal. So the amount of pressure, we'll call voltage pressure, so the amount of pressure that truly is available mathematically using that RMS. And that is how we look at how a circuit is going to work, how much push is there to do, if it's lighting a simple light bulb, or if it's going to be run an injector circuit, whatever it might be, we need to know that value, and that value is critical. So you can see, very smooth, does what it's supposed to do. Okay, the next meter is the 575E. It's a little different animal here. This has got a built-in amp probe. It's a category 3 meter. It's kind of a crossover style meter. It can be used in automotive. It can be used in electrical industry, so it has multi-purpose. And you remember, our industry is moving more and more toward the electrical industry, and with solar and wind, and that the electrical industry is moving more and more toward our area. So these industries are slowly merging together. We're dealing with high voltage DC, three-phase, in a three-phase output in our hybrid and EV cars, and they're looking at big DC systems when you get to solar. So you got to think about them two industries moving slowly together. So let's go ahead and run this one through its paces. A little simpler hookup on this one. We only got two to choose from. Again, we're going to go ahead, just simply put an input standard DC value, moving into it. Responses as the other ones, as expected. CAT meter, and I stated earlier it was a CAT3 level meter. So I keep thinking of hurricanes. That's a little humor here. So the safety rating on it, so imagine what you're going to be using this for. Let's move over here to the fixed duty cycle, varying frequency. Just like the last one, it stayed in there. It's doing a pretty darn good job. Okay, so the range, you can see it's running very similar to the previous meters, as one would expect to see. I see very little, if any, variance. We're going to move over here to the varying duty cycle now. It tracks real well. It does not have a bar graph on it, so it's a little different animal from that perspective. Again, a little more of a utility style meter. A good choice on meters. I do a little bit of wind and solar work too from a troubleshooting, and this meter has been very beneficial. It's really one I grab if I'm going to be helping with any, I guess we'd say, industrial solar type environment. If I'm going to try helping a tech out, this is a meter that I typically grab for that application. Okay, the next meter is the 650C. It's a little different animal here. This is a higher end meter that is intended for the EV and hybrid market. Can use on any traditional automotive environment, but it also works really well, and it's intended to work in that. So we're just going to look at the DC portion right now of it. So a little different hookup here. Our conventional banana connections here for our volts and ohms. We do have a high voltage portion for checking the condition of the high voltage wiring on an EV or a hybrid. It's something I will be doing a future video again on that area. Let's run it through its paces here. So we're now running it through the condition, just looking at the DC voltage up and down. The display is very easy to view. Okay, let's move over to our fixed duty cycle, varying frequency. Again, our numbers are staying right where I'd expect them, well within that range. So again, this is a higher end specific, but it's still going to have to do all the basic work and also leap up to the next level of performance, and that is going to be in our hybrid and EV environment. So hybrids and EVs still have all the low voltage 12 volt systems on there, so you have to do both. So you got to think about it in a different environment. Plus, this is a category 3 and a category 4 meter, so it's intended, we can use it in that high voltage environment. It's intended to keep the meter safe and you safe. The next one here we're going to hook up is over to our varying duty cycle. So the length of time it's on, it tracks very accurately along this line. So we have a variety of meters that are available out there. So when you're making a purchase of a meter, if it's Snap-on or one of the others, make sure the key there is to buy a high-end, high-quality meter. I've been doing this drivability work for an awful lot of years, since I can tell you about from the original feedback carburetors to early fuel injection, electronic ignition. I've got a few years of experience, and that experience has taught me one thing, and that's why a quality piece of equipment that is accurate. If you got inaccurate information, like a lot of you, I'll help with technical troubleshooting to other people, but if they can't call me with accurate information using a cheap little whatever brand generic meter, and their number doesn't match what I would anticipate seeing on that sensor, I can also give the same bad information, taking that bad information, give them bad diagnosis. So the key to troubleshooting isn't necessarily how much money you spend, but how high a quality you could afford to have. And in my world, the diagnostic world, the key to things are the quality of that information from a troubleshooting standpoint. Well, I hope this information was valuable, and please subscribe, and I will see you in the next episode.